All right, let's look at problem 5 from section 2.1. A ball is thrown into the air with a velocity of 40 feet per second, and its height in feet t seconds later is given by this equation here. We're supposed to find the average velocity for these various time periods. So remember, the way we do average velocity, we do f of b minus f of a over b minus a. Now for all of these, we're going to use a is 2, and b is going to be different values given by these. So for part 1, where it says for a half second, we're looking at this one. A is 2 and b is 2.5. So what I'm going to do to find this average velocity is f of 2.5 minus f of 2 over 2.5 minus 2. All right, to get f of 2.5, I'm going to come over here to the side and make a chart. Here's t and here's f of t. So I'm going to need 2 and 2.5. So f of 2 is 40 times 2 minus 16 times 2 squared. Let's see, what is that? 80 minus 16 times 4. It's 16. And if we do f of 2.5, that's 40 times 2.5 minus 16 times 2.5 squared. That's 0. All right, so what we've got here is 0 minus 16 over 2.5 minus 2. That gives me negative 32. All right, for part 2, before we do part 2, let's just say what this is. This is the average velocity from t equals 2 to t equals 2.5. So that's the average speed of this ball over that half-second interval. All right, for part 2, we're doing the 0.1 seconds. So we've got A is 2, B is 2.1. So we get this. Now I've already got f of 2, but let's see, what is f of 2.1? I'm not going to write that down. I'm just going to put it in my calculator. 40 times 2.1 minus 16 times 2.1 squared is 13.44. And I'm not rounding that off. That's exact, 13.44. 2.1 minus 2 is 0.1. So 13.44 minus 16 equals that. Divided by 0.1 equals that. I didn't type that in right. Let me do that again. 13.44 minus 16 equals that. Divided by 0.1 equals negative 25.6. Now, I didn't put any units on this, but this is in, this is a average velocity, so this is feet per second. All right. If I do 3, that's f of 2.05 minus f of 2 over 2.05 minus 2. Going to do f of 2.05 up here. So I'm calling it f. I guess I should mention I'm using this as my f. F of t is 40t minus 16t squared. I'm just calling it f instead of y, but same thing. So 40 times 2.05 times minus 16 times 2.05 squared equals that. I get 14.76. Subtract 16 from it. Divide by 0.05. That gives me negative 24.8 feet per second. That's the average speed over 0.05 seconds. And if I do the last one, that's 0.01. All right, so f of 2.01 let's see, 2.01 times 40 minus 16 times 2.01 squared gives me 15.7584. So if I put that in here, I get negative 24.16. All right, so this is over an even shorter interval of time. This is the average speed over 0.01 seconds. It might not be totally obvious what's going on here, because the second part says estimate the instantaneous velocity when t equals 2. What you want to do is look and see, what are these numbers getting closer to? 32, this. It might not be totally obvious just from looking at these numbers. So let's do one more. Let's do f of 0.0001 minus f of 2 over 2.0001 minus 2. What this is the average velocity during that, that's 1/10 of a millisecond. And this should be a 2 right here. I'm going to plug this in. Let's see, 40 times 2.0001 minus 16 times 2.0001 squared. This gives me 15.99759984. Subtract 16 from that. Divide by 0.0001. And it gives me 24.0016. So these numbers, they're getting closer and closer to 24. So the answer to part B is 24 feet per second. This would probably be easier to see if we did it on Desmos, where we could plug in more and more values that get smaller and smaller, or rather get closer and closer to 2. But this is our instantaneous velocity, and it should be negative 24 feet per second.